I'm Harry Glorikian, and this is Moneyball Medicine, the interview podcast where we meet researchers, entrepreneurs, and physicians who are using the power of data to improve patient health and make healthcare delivery more efficient. You can think of each episode as a new chapter in the never-ending audio version of my 2017 book, Moneyball Medicine, Thriving in the New Data-Driven Healthcare Market. Dr. Chung, welcome to the show.
Thank you for having me today.
So I was just saying to you earlier, I feel like I almost know you from watching you on PBS and watching you interact with your patients. So you'll forgive me if I'm more comfortable than actually meeting you for the first time face to face, or I should say virtually.
Right.
I think we've been doing this too long now. But I know we're going to talk a lot about your program Spark today, but I'd like to sort of start with a little bit of maybe of history and some background. It seems like one big question that attracts you above all others is the genetic basis of human disease. And so how did you first get interested in that?
Right. So I'll go way, way back. I think I've always known that I wanted to go into science and medicine and tried to figure out a way to put things together. And for me, I guess the moment, and you'll be able to calculate my age from this, but the year that I started my MD PhD training program was the year the announcement was made that we would start the Human Genome Project. And I knew I already had a passion for what we call inborn errors of metabolism or metabolic diseases, but it became very clear to me that we would have insight into the genes in the genome to treat conditions like that, plus other ones as well. And an MD PhD program takes a long time to finish your entire training, going to graduate school and medical school and residency and fellowship and all of those things. And so you could project out that it might be as long as 15 years before I would finish my training. And if you looked at the projections for how long it would take to finish the genome, they basically converged about the same time. And I'm one of these people, I like to think that I'm a strategic planner and visionary. I don't want to sound egotistical on this, but I am a planner. And as I started planning, I thought to myself, well, this is really going to be incredible, the power that we'll have as a scientific and medical community. And this whole job description doesn't exist. So we are going to need people to be essentially genomicists, a brand new field of both science and medicine. And I kind of like puzzles. I like logic and I like having definitive answers. And that's what I think that genetics often provides us. And so it's really with the excitement of the opportunities with a brand new field, along with just the way my mind works, that this was really perfect. And I was lucky, I have to admit, to be able to discover that early in my career. So what I start out to do almost the first day of medical school has really been what I've continued to do for my entire career. So anyway.
Well, that's incredibly lucky. I mean, I do believe in a process and a plan. I can't say that at a young age like you, I knew exactly what I was going to do when I grew up. It seems to be in the same area of biology, but I think that's the only common theme that I would say. So this program, Spark, grew out of the existing Simmons Foundation called Safari, right? The Simmons Foundation Autism Research Initiative. You were on the board of Safari for a long time, and then you became a program director of clinical research. Can you talk about why you felt drawn deeper and deeper into specifically autism research?
Sure. So I'm trained as a pediatrician and a medical geneticist, and a fair number of the patients that I see, and this was true pre-existing before Safari or Spark ever came along, but a lot of my patients have neurodevelopmental conditions and or autism. So it's a common reason for people coming to see us. Over my career, a lot has changed in terms of our ability to understand the underlying etiology, especially the genetic etiology. And I will give credit, that was in large part due to the Safari program at the Simons Foundation. They really did have this original vision in terms of we needed to understand the brain and behavior for individuals across the spectrum, and that a really powerful tool to do that would be genetics. It's not all genetics, I want to be clear about that, and it's a wide spectrum. But I got pulled in just because of my expertise as a geneticist to, advise the Safari program. And as you said, It started out as advice, and due to individuals who were there and got to know me and thought I might be able to contribute in even bigger ways, got sort of pulled from the outside to the inside, so to speak. And as that happened, in understanding what the gaps were, SPARK, or Simon's Foundation Powering Autism Research for Knowledge is the acronym. That was a vision, realizing that to really make the scientific inroads we needed to do, we needed to think big. And that's because autism is not one condition. It's quite heterogeneous. It's quite complicated in terms of etiologies. And we really need to have hard foundations, really solid evidence to be able to know what direction to go with the science. And that genetics provides that solid foundation.
Yeah, I was trying to get ready for this, and I was trying to do as much reading as I could, and I realized, like, we know some things, but there's a lot we don't know, and then there's certain things that seem to trigger it, and we don't fully understand what all those things are. It's a very interesting sort of set of reading that I went through very quickly. So I'm probably like a millimeter deep and pretty wide compared to you, but it is interesting how genomics and genetics are really driving a lot of areas that we see right now. It's funny because I remember when someone way back in the beginning, so I'm dating myself also, was said, "Why would you sequence anything?" And now it's like we want to sequence everything,
Yeah.
and the information that it's giving us. So can you give us a high level explanation of what Spark is and how different it is from some of the previous studies of autism spectrum disorder, and in terms of scale and goals, and when did you decide and how did you decide to embark on this? Because I was reading the study. I mean, it's a pretty ambitious goal.
Yep. So again, at the Simons Foundation, we had started out with something called the Simons Simplex Collection. And I think of that as sort of the first foray into the genomics. That was to give you a sense of order of magnitude, about 2,500 individuals with autism. So, a big order, 20-fold difference in terms of the original goals, at least for Spark. But that was, I think of as being very careful in terms of making sure the individuals within that Simon Simplex collection, they went through very extensive in-person evaluations with masterful clinicians, psychologists, to make sure the diagnosis was unambiguous, and then had the genomics sort of layered on top of that. And I won't get into the specifics of cost per person to run through that, but that was really, I think of as the platinum version. And that was important for the field to be able to have that again as a solid foundation, and to be able to make some statistical arguments about what sample size did you need to be able to get to understand the entire complexity of autism. So it was definitely foundational and necessary. But in terms of being able to do that with about 2,500 individuals, you could make estimates that in terms of the number of genes that would be involved in autism, it would be around the order of 500. And so that's just for, a certain portion of the spectrum as well. And you can understand, therefore, the complexity in terms of what we're talking about. And I'm just, because I know there are some people who may not understand exactly what I'm talking about, let me just be a little bit more granular. For people who come in to see me with a child with autism example, I'll have some individuals who may be nonverbal. They will never be verbal. That is, they'll never talk. They may be able to communicate in some way, but they may be intellectually disabled. They may have seizures or epilepsy. They may have even medical problems associated with that. And that's one portion of the spectrum. To another portion of the spectrum are individuals who are just incredible in that their mind works differently. It doesn't necessarily work in a wrong way. It just works differently. And they see the world in a different way. And oftentimes, I have to say, are profoundly insightful in terms of problem solving, because they do come at it from a different direction. And they do have just fresh eyes to be able to look at complex problems. So, and again, I want to be very clear in terms of how I'm talking about this. I don't consider autism a disease in that way. It's a difference, right, in terms of all of
Yeah.
what we're talking about. And I want to be very clear also in terms of the genetics that this is not to get rid of anyone. This is not to be able to have a eugenics movement where we're trying to eliminate individuals with autism. It has nothing at all to do with that. It really has to do with understanding the underlying biology of how the brain works, because we've really been so much in the dark that people had theories and hypotheses, and they'd waste a lot of energy doing the wrong science because it wasn't based on that foundation of really truth with a capital T. What are the molecules in the brain? What are the different parts of the brain that are involved? How does it change over time? We really needed that foundational information to go from kind of the dark ages of autism research into the modern age and era. And so in doing so, that's the Simon Simplex collection found, allowed us to see what sample size did we need. So we started doing some rigorous statistical calculations of how many we'd need to get to that goal of having maybe not every single gene, but the majority of genes. And that's where the calculation of having 50,000 families originally came up. And so that was our original goal, to be able to scale that, 20-fold higher than what we'd done with Simon Simplex collection. But if you started looking at number one, who was able to participate, like who literally could give up a couple days of their life to go in for these evaluations, who was close enough to one of these study centers to do it, it was partially an equity issue for me, that I wanted to make sure everyone could get access to be part of understanding better and to be represented, because if you're not represented, your voice may not be heard in terms of the research. So part of it was from that point of view, is from a convenience point of view, making sure that individuals wherever in the United States, if they wanted to be in their pajamas at 11 o'clock at night to be able to do this, they could do it then. And it wasn't so burdensome. So the whole process, takes maybe an hour or so to be able to register and become part of this. Not to say that you can't do more than that first hour, but to start this off, it becomes easier. So it was with that. And, we've had, in terms of timing, we've had lots of ability to do things online that we couldn't do before. So when we first started this, the internet wasn't as evolved as it is, and there's just a lot more we can do from home. And in general, one of the parts about Spark that I think is really important is that it's meant to capture people where they are. And so I mean that both in terms of just the convenience of participating. I also mean in terms of behaviors. And so again, as a clinician, I have children with autism who come into my office who, I have to admit, it's a terrible experience for them. They're petrified in terms of, they like to understand what's coming. They don't like surprises. They get anxious. Being out of their elements is really hard for them. And so being able to do things where they're on their home turf, they're on their home territory, and being able to capture behaviors where they really are, rather than our artificial environments of being at a laboratory and at a university, at a hospital, I think is really important to truly see what life is like for individuals. So we're trying to do all of those things in terms of really capturing more of accurate information, more data. So in terms of doing this, not just the one time you can come in and be evaluated, but over your life course. And so that's one of the things about Spark, is this is not a one and done type of snapshot of who you are. This is really thinking about a life course. And I want to emphasize this. One of the other things about Spark is not just the number of individuals, but it's the longevity of what we're planning to do. We're celebrating our 5th anniversary this year. And from my point of view, we're planning on going this for a lot longer. I don't know if it's going to be 50 years. I don't know if I'll last for myself for 50 years, but this is, I tell people who will understand what I mean, this is meant to be kind of like the Framingham of autism. In other words, being able to really see people through different changes over their life course, different stages of life, different challenges, trajectories of how things evolve, and importantly, what we can do to change that trajectory potentially, or support people better, so that sometimes when people fall through the cracks with young adults, especially, is one area that I'm mindful of. How do we prop them up? How do we make sure that transition is easier? And so, like I said, for anyone, wherever they are on the spectrum, I think there's always sometime, someplace in your life where you need an extra helping hand. And so I hope this will start to provide that evidence base for where we can provide that helping hand and have the greatest potential impact.
Yeah, no, it's this term we're using, autism, is quite captures a very broad set of people, as you indicated. Like, Elon Musk recently got up on SNL, right? Um, and you had to know that he was a little off anyway before that. But I actually believe that people like that can see the world in a certain light through a certain lens that a lot of other people would be like, I have no idea what you're talking about. I can't see it. So all of these people, right, on one spectrum or the other, which I think all of them add value as they're going through their lives. But now, the other interesting part of this study is you guys are sharing the results with participants, right? Which is not usual and not, I don't think, trivial to do.
Right.
So you've got unprecedented level of engagement and data return to individuals and their families. You're not just returning genetic data, but aggregate reports, which in accessible language, which, you know, I'm trying to write. I've just finished my third book trying to write it more accessible, and of our world, and I can tell you that was truly challenging. So what was the philosophy behind that, and what are your challenges around trying to do that?
Right. So you're absolutely right. I think in a very good way, we've been from the very beginning and even in the planning stages of this, had participants as part of that planning process, and they still are literally on our staff, on everything that we do. They are integrated in our teams. So let me paint a picture for you about some of the details of what you're talking about. So as of this morning, as an example, we have over 100,000 individuals with autism in Spark. We have over 265,000 total participants. So the reason why the difference for those is some of those are parents, for instance, of individuals with autism or siblings, because we do encourage families to participate. So you can see that this is massive, right? This is over 250,000 people that we're trying to be able to in some way juggle with all of this. And so for me, that was, you know, I don't, unlike most of my other research studies, I don't personally know every single person in the study. I never will, unfortunately, but we do have anchors of 31 clinical sites around the country. So that's one of the things that we do to make sure that we have our finger on the pulse in some way of our participants. But I will also admit you could just be, like I said, in your jammies at 11 o'clock at night tonight and Google Spark for Autism and be able to find and sign up for this. You know, there's no, you don't have to be at one of these sites to do this. You're right that the philosophy I heard from our participants from the very beginning, and some people may have heard this term, is nothing about us without us. And so in terms of research, the idea that we want to be, as research participants, we want to be part of the research team. We want to be able to have a voice. We want to help you do your job better as researchers. So, you know, it's not just in a selfish way, it's about what's going to really make us committed to doing this, not as a one and done study, but as the picture I painted, to be able to continue to participate for decades forward. And so in hearing that, and in hearing what was important to participants, keeping in mind that I can't do everything for everyone, you know, we have to have compromises in this, it became important for people to have access to their genetic information, but not just like give me a flash drive with my raw data, right? That's not helpful. If you're interpreting this information to understand genetic causes of autism and you find that, for me, let me know about that. And in addition, and I am proud of the way we did this not with just sort of sending someone an email and sending, okay, well, guess what? You've got a Shank3 variant and this is the cause of your autism. We do this, and I think about this for myself. What would I want to do for me? What would I want to do for my family? If this were my son, how would I want this done if I weren't a geneticist? And so we built in, I call it choose your own adventure, but we give people choice in the sense that when we return, number one, it costs no one anything. Let me be very clear about that. So it's not like you're buying a test or anything. If anything, not if anything, we do give you a token of a gift certificate to thank you for your time, because we know it takes time to be able to do this, but we pay for everything with this. And so we do, for those that are aficionados, we do a process called exome sequencing to be able to look at comprehensively across the genome as we do this. And it's about, right now, as of today, about 10% of our participants where we find something that we can be pretty certain is the cause of the autism in the family. And we, again, pay for this ourselves to have a second group of people double check, make sure it's correct. And then the choose your own adventure is either you can choose to have your own doctor give you that information back and explain it to you, or if you don't feel like your doctor is the best person to do it, because maybe they're not a geneticist, maybe they don't have any idea what we're talking about, we pay for the study centrally to have a trained set of genetic counselors be able to return the information. And I and my team have personally written out what we call brochures in, as you were talking about, lay person language that describe each one of the over 100 conditions that we now return. And so it was a lot of work to write each one of those brochures for each one of those conditions, and to keep them up to date. But that's how committed we are to this community. That's how important I think it is. And
I almost feel like I need to sit down. That's just the enormity of that task is extremely commendable. Like I can't believe
but wait, there's
getting a
more.
commercial enterprise
Well,
like to do that, right, is not trivial. So that's incredible.
but wait, this is like the Ginsu knife set. But wait, there's more. So So we also appreciate that not everyone is going to have a genetic result. And so we also have parents, for instance, that are completing questionnaires that tell us about how their child is doing in terms of behaviors or, things that are related to autism or behavioral issues. And I have to say, during COVID especially, this was a big issue for many people, not just individuals with autism, but about psychological differences and making adjustments during COVID. So within that, we give, and these are again standard psychometric tests that are used so-called in the industry. So in other words, by psychologists who are practicing, we give that information back to families. We use infographics. And so all of this has been test driven in plain language with groups of individuals that are average parents, individuals with autism. We have a commendable group of about 80 of our participants that sit on our board, again, giving us feedback before we go live with any of this, telling us how to tweak it, how to make this more accessible, using different infographics to be able to make this easy. But every one of those things that we can return, then we return it to our participants. We have something called a research match program. So we have over 150 researchers who use Spark as a way of letting the community know about the research they're doing and being able to match Spark participants with research, so that this is, as you can see, it continues to kind of organically grow,
Yep.
not just Spark, but the entire research community. And a requirement for every one of those researchers is that when they complete their research, they have to actually give that information back to the people who participated in the research and to the Spark community in lay language. So in a way that families and individuals can access and understand it. And we have many of them give webinars or be featured in our newsletter, but the whole process is we're learning together. And I want people to see how science is done. I want them to be part of like the front lines, like they're getting the preview in terms of hot off the presses information. So with this, hopefully this is a movement in science. It's not just Spark. I hope all people do this.
I was going to say, I think you need to teach a master class on how to do this, because I'm not familiar. Maybe somebody else is doing it, but I'm not familiar with it. Usually I get gobbledygook
Hmm.
back. I mean, I just actually volunteered to do a diagnostic clinical trial, and it was, and I'm in the business, and I was reading what they wanted, and I was like, I don't understand this at all. I don't
Yep.
understand what you want from me. I don't understand what I'm going to get back. I don't understand anything. I'm not participating. I don't have time for this.
Yep.
So, but all the stuff you said now really rings in my head of A, data management challenge, B, analytics challenge, and C, how do you automate some of this? Because the first thing that goes into my head is there, some aspect of AI or machine learning that can do some of this? Because if I'm not mistaken, every time you discover more variants, you're going back and reanalyzing the genomic data. And that, becomes exponentially a bigger and bigger task if there isn't some level of automation to sort of make part of that more turnkey.
Right.
So what are you doing there?
Yep. So you're absolutely right about we have thought about ways to scale this. Scale is one of my favorite words right now, because you're right that each time we get more people that come in and more data, we turn the crank one more time. Knowledge is increasing around us about the brain and behavior. We're adding that and putting that back in, and then again, increasing the robustness of what we do. And we do want to be really rigorous in terms of as we're doing this. So that's on the genetic side. And so there are ways of being able to do that. I will say it takes more and more in terms of computing time or sort of, person power to do this. Bitcoin, by the way, has been a problem. They're buying a lot of servers. They need to, free up some of those for science. But anyway, but aside from that, there's also the issue in terms of people report to us behaviors, and in an interesting way. And it's just kind of what happens when you do science this way. Not everyone is perfect in terms of how they decide to participate. And I get that. And so what I mean by that is there's missingness of data. We as researchers have a lot of, we realize that we've used the machine learning in some ways to fill in those missing pieces. And so what we've tried to do is use machine learning. I talked about a spectrum, for instance, and people are at different ends of the spectrum. That ends up being incredibly important to interpret the genomic information as well as information about other people in the family and how their genetics go with their own particular place on the spectrum. And so putting all that together, we can get a profile with machine learning to fill in some of the gaps, fill in some of the blanks, understand issues with trajectory, and then combine that with the genetics. And so the good thing, and this is another reason why we set up Spark the way it is, I'll be very clear to anyone who's thinking about this, either as a contributor or as a user, everything is de-identified, of course, so no one knows who any participant is. But I set this up originally so that the broad research community would be able to think about these problems, and I tried to de-risk it for any scientist who wanted to enter this. So as a data scientist, for instance, you may not be an expert in autism, but I want you to be able to contribute in terms of doing this. And so the way this is set up again is it's very the entry to access this is we make sure you're a real bona fide researcher. We do go through a rigorous check of that, but you don't have to be an autism researcher. You could be in industry, you could be in academia, you could be at a private foundation. We just want to make sure you're doing good science. And I have been seeing that many of the people who are using the data are not necessarily, they didn't start out as autism researchers. They simply are data scientists, computational biologists who are able to look at the data in interesting ways. And I think the more we can bring smart people to the table in this, the faster we'll get some of the answers we need.
It's interesting because I can't remember. I want to say like 2 episodes that I just released ago. I was interviewing a company that is their expertise is in genomics, but they're generally focused on healthcare, and they've built a mesh container platform that seems to speed up all the sorts of things that you're talking about and make it much easier for an average user to sort of play with the data and see and release certain insights. The company's called Tag Bio, if it helps at all. Did you ever think when you were getting your MD PhD that you'd have to become a data scientist or an IT manager?
So not exactly. And in fact, so anyway, I'll tell you sort of how I grew up. I was actually, as growing up, if you had asked me what my natural proclivity or skill was, I was definitely mathematically inclined. I was very data science inclined, very mathematically inclined, and probably even too good in some ways for my own shoes, because I kind of got ahead of myself in terms of taking very advanced courses at an early age. I'll never forget this conversation though. I had a discussion with my math professor as an undergraduate and said, I'm really good at this stuff, but what can I do with a degree in math? And he said, oh, well, you can go work at an insurance company. You can be an actuary on, you can figure out what rates, people should be paying in terms of their insurance. And I said, really, that's what you do with a math degree? And like literally I did a 180 pivot and said, that's not worth, going into for that. And that was, I have to admit, unfortunate. And I'm not saying everything happens for a reason. I have no regrets in terms of what I've done with my life. I think that, I found my home and, a great thing to do. But I do have some regrets that, he had that influence on me in that way. So, I could have seen myself the time when I grew up, we were just starting to have personal computers, we didn't
Yep.
even have emails or internet or, it's a completely different world than when I was training. So I will admit that a lot of what I do is done by others. I think that's a good thing. I will say team science is incredibly important. And even though I'm here talking to you today, really I'm representing literally hundreds of scientists behind the teams that are actually doing the hard work, whether it's coding to be able to make our interfaces for users valuable, whether it's data scientists analyzing the data, psychologists, neurobiologists, they're just amazing people that are behind the scenes doing all of this. And so when it comes to a lot of the really heavy lifting, I will admit that they're the ones doing the heavy lifting. And, in a good way, I think I've got the vision to guide the ship, but there are a lot of really smart, especially young minds that are driving a lot of the science.
So I want to switch here and switch to recruitment here just for a minute or so, because I also want to ask some of the listeners to point people in the direction of this study, right? The more people, the better. But um, where are you now from a numbers perspective? The last numbers that I saw were 18,000 individuals in 2017 and 28,000 family members on top of that. I'm sure it's grown since then, but what are the numbers right now?
Yep. So as I was saying, the numbers are in terms of people registered, just over 100,000 with autism and just over, it's about 265,000 total. So I'm not going to, anyway, I'll go ahead and just say it. So there are individuals who get stuck at various different stages in the process. I will say dads seem to get stuck more than moms do, and I can understand dads are busy. But some of the numbers you were quoting, for instance, is we have registration. We also have send out a saliva kit for people to be able to donate a DNA sample. So they spit in a tube and they send that back. And so we have a fair number of people that get stuck at that point, and dads in particular. When we started out the sequencing, one of the things that I'll just give a little science behind this is that we call them de novo genetic variants. So variants
Mhm.
that are brand new in the individual with autism are oftentimes some of that 10% that we'll recognize as a cause of autism. I'm not saying those are the only causes, but those are the ones we recognize at this point. So it became and has always been really critical to have both mother and father in the individual with autism whenever possible, so that we could very quickly recognize what was different in the child with autism from either their mother or father. Having them in comparison just like makes that sort of crank you were turning about very easy to turn. We've had issues in terms of being able to get, we call them dangling dads, but dads that, just haven't quite gotten it together and have found the time or found their kid to send that back in. And that has decreased the number of family units, mothers, fathers, and children with autism that we can look at. And so has limited some of the analyses that we do. On the other hand, as I said, we want to make sure everyone that contributes is able to contribute. So we have our analyses now include every single person who's contributed a saliva sample to Spark, at least that, saliva sample that's been sufficient to be able to sequence. So whether it's just one person or one person and their mother or one person and their father, everyone is represented in what Spark does. It's just a question, as I said, of what we can recognize. I do want to call out, and this may or may not be obvious to listeners, but I do want to call out it is really important for everyone to be represented because of the number of types of autisms, but also I think it's an equity issue in terms of ancestral diversity. So where in the world your family came from, if they came from China, if they came from Brazil, if they came from Ghana, wherever in the world they came from, it's really important because the genetic variants from our ancestors differ depending on where in the world you came from. And right now, in terms of genetics, about 80% of the genetic data we have as part of research comes from individuals from about 20% of the world's population. And so we are overrepresented for individuals of European ancestry, which means that in terms of being able to recognize those genetic factors, we do a pretty good job if you're of European ancestry. We don't do nearly as good a job, though, if your family comes from other parts of the world. And both in terms of equity and making sure that we don't increase this gap in terms of genomic medicine and utility of this information, it's really important to me that everyone gets the same shot at this. And that's part of, like I said, why we made this so easy for people. And I hope they'll take advantage of that because some people won't get this information any other way.
But it's not, that's, I mean, I we need to be inclusive of everybody, but when I look at the trajectory and the how all of these technologies across a number of different areas, that seems to be a common theme
Mhm.
is, you know, who accessed it first, where do we have the most data, and what do we need to do next? And I look at all these technologies as on an evolutionary scale,
Mhm.
right? Where we're continuing to add, and how do we get to more people? How do we make it easier for people to participate, et cetera? Because when we were at Applied Biosystems and there were sequencers right there, I mean, you could just, it was pretty easy to participate.
Yep.
Whereas for other people who don't have access, or it's not as, I mean, if D'Souza and Illumina does what he wants to, where he's talking about a $60 whole genome,
Yep.
uh, there'll be things that we'll be doing that we haven't even thought of yet.
Absolutely. And we've thought of some of those things. So the next time you have me on, we'll talk about some of those other things.
Okay, well,
But I, in so although there's the accessibility, I do think there are some issues, understandable issues about trust. And do I want you to have my genome? Do I trust you to have my genome? Could you do something? Is some police officer going to arrest me, or, try and somehow plant evidence that's going to be used against me in some way? So I think there are all sorts of reasons why certain members of our community don't feel comfortable with participating. And I totally get that. I think part of it is I want to make it easy for people. I also want to make sure, and it's through Spark that we're doing this, is to understand and have those individuals have a seat at the table, be able to address as many of those concerns as we have, so we can build that trust and build that, shared vision and shared goal in terms of moving the science forward. And I say this, and it's slightly different. I'm going to slightly digress, but I also am, as a geneticist, for instance, treat patients, for instance, who have cancer or have a family history of cancer. And I'll just very briefly share a story, which is that I had a patient who happened to be of African American ancestry, and she actually through a very long, long story short, had a family history of breast and ovarian cancer. And although she did the sort of BRCA test that some people talk about, BRCA1 and 2,
mhm.
she did not really get the full understanding of the information from that test because she had a genetic variant that at the time wasn't recognized. It happened to be a real true, what we call disease causing variant to increase the risk of breast and ovarian cancer, but it wasn't recognized because her community, her individuals from the same ancestry weren't represented to be able to distinguish sort of the signal from the noise, if you will. And so that's what happens in terms of, and she ultimately went on to develop metastatic cancer, unfortunately. And so there's this gap that has been evolving and actually gets wider and wider with the more that we depend on using genomic medicine, either to select the right medication or be able to decide what preventative treatments or what increased screening to do. There becomes a wider and wider gap between the haves and the have-nots. And I just want to make sure we narrow that gap. We get back to being equitable.
I totally agree. I mean, I have my own pet peeve stories about BRCA. I mean, I was lucky enough to do. I helped Myriad with some of their strategies, and I got to learn a lot about their database versus everybody else's database.
Mm-hmm.
And so I have my pet peeves on where people should go and get their testing.
Mm-hmm.
But I also agree that being able to explain this to someone is not trivial. That person didn't fall off the turnip truck, right? And the data is changing daily. I used to be able to turn on my computer and I'd be like, oh, I can keep track of that one and keep track of that.
Yeah.
Now it's forget it. If I don't
Yep.
have IT support
Yep.
and somebody who's been studying it, it's, I don't want to say it's relatively impossible, but it's extremely daunting to
Yep.
sort of keep up with what's going on.
So let me
Um,
just, I'm going to say on that note, although it's not directly Spark related, there's some listener out there who this will resonate with. Your point of scalability and to be able to wrangle all of that changing interpretation of the data in real time is very important to me because, like you said, there's a lot that we don't yet know what it means, not just related to autism, but related to a lot of the way our bodies function. And there needs to be a platform, an informatic system that facilitates that you as an individual, your doctor would be great, but you also as an individual can contribute to and engage in to be able to manage your own health.
So I have to tell you, I mean, after all the work I've done and everything that I've tried to write and so on and so forth, this whole idea that everybody has that they're going to have their individual silos is to me a bunch of malarkey,
Mm-hmm.
right? We've all seen that when you put all the mapping information and Google has it, it's an exquisite piece of, useful database that you gets you around, tells you where you need to go, what you need to do. It's not there aren't 50 of them or 100 of them. I mean, in our world, if I think of everybody's individual silo, there's thousands of them.
Yep.
And it should be, I mean, the country itself needs to aggregate this. I know that medical professionals will be like, no, it's my data. It's not your data, it's the patient's data.
Right.
And it should be aggregated. And by aggregation, we can gain more insight into it. But, you know, these are policy issues that every once in a while I try to influence people on. But boy, the technology is moving much faster
Yep.
than the understanding of the people that are writing the policy. And not to digress, but I think if we want to solve problems or at least gain a deeper understanding, until we do that, I think it's just going to be chipping away, except for programs like yours or certain companies that I know that are spending the money to build a massive data set that they can then sift through. But all of this work that you're doing is to, diagnose the patient better, manage the patient better, understand the progression of the patient, but it's also to eventually, I'm assuming, design certain drugs or certain therapeutic interventions that where are you from in that standpoint?
Yep. So we are moving forward. It's not going to happen overnight, but I talk a lot about getting people to the starting line. So we have a sister study for Spark called Simon Searchlight. That's actually, we've been doing that for about 10 years. That now is once you get a diagnosis, a genetic diagnosis, the point is then you've got a group of individuals that all share that same genetic diagnosis. You can learn from each other, you can learn from researchers, and to your point, now you know what starting line and what race you need to line up for, right? Because you're, in terms of a treatment or a support, it's likely to be specific. There may be some commonalities across genes, but in some cases, if you think about a gene therapy or gene editing or gene replacement or something like that, that is going to be at the level of specificity, at least at the gene, and in some cases, maybe even by the genetic variant. So in terms of doing that, number one is that I do think this is going to be, I call it a step function mathematically, right? So there are going to be enabling technologies. And when certain enabling technologies and delivery systems are in place, they're going to be, it's not just going to be one condition that's now treatable, it's going to be a whole class genetically of conditions that are treatable. And it's a matter of, as modules, popping in the right gene into that system and making sure that the window of opportunity for treatment is still open. But as we're doing that, it's important to me that even for conditions that are seemingly very rare, they're in the aggregate quite common, and there are a lot of lessons to be learned from each other as we're doing that. So it's kind of getting everyone lined up. We're starting to think about, and I don't want to put a time frame on it, but it may be as soon as within the next year or two that we'll be starting to actually use treatments in some of the individuals, either in Spark or Simon Searchlight, with one of those genetic events that's amenable to some of these molecular technologies. We have a clinical trial for something called arbaclofen that got shut down by COVID, but hopefully will be opening up again soon. And that will be, it's a small molecule or a pill that you'll take, but for certain individuals with a particular group called 16p11.2 deletions. Again, one genetically defined group, but that clinical trial I hope will be opening up later in 2021. So we are marching forward towards treatments. We also think of, as I said, supports for individuals. So it's not just about changing the person or giving them a drug, but thinking about, what do you need? Is it that you need coaching in terms of how to, ask someone out on a date, how to be able to interview for a job, how to, be able to get your life together to go off to college and live somewhat independently, things like that that may be a little bit more difficult for certain individuals. But how do we deal with some of those things as well? All of these, I think, are going to be incredible opportunities. And like I said, a large part of what I do is try and de-risk all of this. So think about the research community. What does the research community need? What are we going to need for FDA registration? How can I make this easier, more accessible? Like, what are the tools I can put in the toolkit so that if someone's got a hammer, I can point them to all of these nails out here that they can just start hammering one by one and be able to hopefully make a much bigger impact than they could if they just, saw one nail that they could hit. But with this, like I said, it's not going to happen overnight. It's still, I think, when I think back to the last year of what we've had in terms of molecular therapies, things like Spinraza and spinal muscular atrophy have been truly revolutionized. What used to be for me the most common genetic cause of death for infants is now something that we do with newborn screening, and we have a one and done gene therapy. I mean, it's just remarkable. I never in my wildest, dreams 20 years ago would have thought that we would be there. And I think that's part of the, that sort of vision, that way of thinking about things. I wonder and hope that at some point in the not too distant future, we'll be able to identify kids early at a window of opportunity for treatment, line them up for the right safe treatment if they need it, and be able to bend that curve, put them on a different trajectory than they might otherwise have been on. So,
But yeah, I mean, I've spent time, talking to Robert Greene about baby-seq and sequencing, children, and you're right. I mean, if I think about from the day we were starting the Genome Project to now, um, we've revolutionized some areas. I mean, things that were a death sentence or whatever have completely changed. I'm not sure the public or people fully appreciate that. That's why when somebody writes a paper that the genomic sequencing hasn't had an impact, it just drives me nuts.
yeah.
But okay, tell me if because I'd love to do. We've talked about the benefits of all this, but if you could say to why should people donate their genetic data? I want to see if we can get some of the listeners to touch some of the people that they know, or at least get the word out. And then what can the rest of us do to help
Sure.
in this?
So if you'd like to participate, the website is Spark, SPARK, for autism.org. Sparkforautism.org. Right there on that website, on that landing page, there's a tab that says join us today, and that starts down the process of being able to sign up for doing this. You can share that with a friend. Everyone in the United States is welcome who has, we call it a professional diagnosis of autism. So in other words, a psychologist, a doctor, someone has officially said that they have autism, not just that they think it's a possibility, but someone has really said that they do have autism, and of any age. So it could be a 2-year-old to a 50-year-old. And then, as I said, their family members. So that's in terms of doing it. In terms of, like I said, the information that you get back from it, I do hope I will say also as a practicing geneticist, this doesn't replace me in terms of wearing my hat as a doctor providing genetic information. So if you're a pregnant mom out there who has a son with autism and you're worried about, the risk to your baby right now, see a medical doctor about this because it takes us a little while on the research side. I won't be able to get you a result a week later. It does take time. So we're not meaning to replace the medical system. But as you're doing this, I do hope you'll find it helpful, like I said, to get some of your own personal information genetically about autism. And most importantly, it's to be represented. That is that I don't know where the insight is going to come from. And I want to make sure that we have information that's useful to everyone across the spectrum, whether it be by age, whether it be by gender, whether it be by where you live in the United States, whether it be by your gene. There's so many different dimensions, and it changes over the life course that it's a big ask, I realize, but we are committed to doing this. And I will say it's through the generosity of the Simons family and the Simons Foundation that we're committed to this for the long run. I don't have to worry about, will NIH fund this for another 5-year cycle? I don't have to worry about the upturn or the downturn of the economy or fundraising for this year. This is one of the truths in life that I can say this is going to be around for the long term. And so you don't have to worry that this is going to disappear or go down in flames, or that, your samples and your information are going to be stuck in a freezer or a warehouse and no one's going to pay attention to this. This is, and I've emphasized this, but this is what's driving autism research in the United States. There are literally hundreds of researchers that are using this as the way to know better. And if you want to be easily in touch with those researchers, find the cutting edge information, this is an easy way to become an insider. So I hope you'll use the opportunity in whatever way suits you best, but definitely share it with a friend, and hopefully you'll be able to get something out of this too.
No, this is fascinating. I'm really glad that we had the opportunity to talk and expose the listeners to this, because I think what you're doing as a process needs to be replicated in a number of different areas. And then at some point, it would be interesting to have an, a portal that would potentially share and aggregate that information in a way. Um, but because I always think, we just don't know what we don't know yet. And
Right.
there's got to be a way to evolve this as it goes forward. So it was great to talk to you. As I said, I feel like I know you from the PBS show, but great to actually meet you in person, and look forward to publishing the episode and getting people excited about this opportunity.
Well, thanks for having me and helping to increase the awareness. And thanks for what you do. Educating the public about what science and big data are about is so incredible to educate all of us so that we can make better decisions.
Excellent. Thank you.